all the rules about factoring I taught you still apply, but this is one that I do hope you recognize and see right away. We're going to do it as if I don't know the shortcut, but then I'll explain the shortcut this is one I can explain pretty well, so I'll try my best. I'm factoring. There's no common factor, so I'm definitely kicking this off with the idea that I've got two sets of parentheses. I do recognize, though, that 4 is a perfect square, it's 2 times 2, and 25 is a perfect square, it's 5 times 5, and they're being subtracted. So I love when I see that, because here's what that means. It means that there was an m term, but it canceled. It went away. It's gone. And the only way for that to happen is like this. If I think about two things that multiply to make 4m squared, I'm going to use a 2m and a 2m. If I want things that multiply to make a negative 25, I'm going to try 5 and negative 5. Now, it needs to be the case that this inner product and this outer product need to combine and they need to make nothing, because this really is basically 4m squared plus no m's minus 25. And lo and behold, this inner product is negative 10m, the outer is positive 10m. If I do combine these, they do make 0. And so my final answer would definitely be, if I were to multiply this out, I would have this thing back again. This is my factored answer. This is a great difference of perfect squares, is something you see often because we're trying to be nice. And basically, if you recognize it's a perfect square, and this is also a perfect square, and they're being subtracted, it's always going to be the case that it's whatever you multiply by itself to get this is the first thing. Whatever you multiply by itself to get this is the second thing, and it's always plus or minus. You could put the minus here and the plus here, the minus here, the plus here. It doesn't matter as long as one's positive and one's negative. And it'll be that way every single time. So these are like super quick.